How can you avoid JavaScript recursion, Stack Overflow? Imagine trying to climb a staircase that keeps going up and up without end. Eventually, you run out of steps to stand on. That's what happens with JavaScript recursion when the call stack gets too full. When a recursive function calls itself too many times, it can cause a Stack Overflow error. This happens because each call adds a new frame to the call stack, which is limited in size. If the recursion is not controlled, the stack can fill up and crash your program. To prevent this, start by making sure your recursive functions have clear base cases. These are conditions that stop the recursion from continuing forever. Without a proper base case, the function will keep calling itself endlessly, leading to Stack Overflow. Next, think about limiting how deep your recursion can go. If your recursive process depends on user input or large data, add checks to stop recursion after a certain number of steps. This way, you prevent the call stack from growing too big. Another way to avoid Stack Overflow is to convert recursion into iteration. Instead of calling the function repeatedly, use loops like for or while. Loops use a fixed amount of stack space, so they won't cause overflow even with many iterations. You can also use a technique called a trampoline function. This method transforms recursive calls into a series of function objects that are invoked in a loop. It flattens the recursion into iteration, keeping the call stack small. Some JavaScript engines support tail call optimization. This means if your recursive function is written in tail recursive style, the engine can reuse the current stack frame instead of creating a new one. This can help avoid overflow, but support is not universal. Managing your own stack data structure is another option. Instead of relying on the call stack, you can use an array to simulate recursion. This approach keeps your program from hitting the call stack limit. Finally, breaking recursion into asynchronous steps can help. Using set timeout or promises schedules each recursive call separately, allowing the call stack to clear between steps. This way, you can run deep recursive processes without crashing. Understanding how functions and asynchronous JavaScript work together helps you see how recursion impacts the call stack. By applying these strategies, you can write recursive functions that are safe and efficient, even for large inputs. For example, calculating factorials recursively becomes safe when you add a proper base case or convert it into an iterative process. Mastering these techniques means you can create recursive functions that run smoothly without risking Stack Overflow errors. It's all about controlling how and when your functions call themselves, making your code more reliable and less prone to crashes.